Hello, this is Sujit. Welcome to Physics 2020. So today in this session we are going to discuss the problems, the remaining 10 problems of graphical analysis of motion. So in the previous section we have discussed 10 problems in the section of graphical analysis of motion. So in this section we discuss the remaining 10 problems of graphical analysis of motion. So far we have discussed in this on my channel Physics 2020, that is motion in a straight line. Okay, so only one topic remaining in this chapter, that is motion in a straight line, that is nothing but that is a relative velocity in one dimension. So in the coming session we will discuss the concepts and problems of relative velocity of one dimension. Okay, so my dear students, if you didn't subscribe my channel, please subscribe the channel and also press the bell icon for the notification of the upcoming videos. And if you are thinking that is my classes are useful for the preparation of Jeemains and Neet exam, so please share the video to your friends also. Okay. Anyway, we start with that is problems of graphical analysis of motion. So 11th problem, a car starting from rest accelerates at the rate f through a distance s, then continues at a constant speed and then decelerates at the rate f by 2 to come to rest. The total distance travelled is 15s, then. So listen here, these are the four options given for this question. S is equal to ft, s is equal to 1 by 6 ft square, s is equal to 1 by 72 ft square, and s is equal to 1 by 4 ft square. So what is given in the question? That is a car starting from rest. Okay, that is the initial velocity of the car is 0 and it moves with the constant acceleration f for a distance s. Then it starts with the car starts from rest and moves a distance s with a constant acceleration f. And after that it moves with it attains a constant speed, and after a particular time interval the car moves with a constant speed. Okay, constant speed. So after that the car starts to decelerate at the rate f by 2 to come to rest. So after that the car starts to decelerate, okay, with a constant deceleration f by 2, and finally the car comes to rest. So the total distance travelled is 15 years. Means that is the total journey of the car we can divide it into three parts. So the first part of the motion is accelerated motion, second part of the motion that is the car moves with a constant speed, and third part of the motion that is the decelerated motion. Okay, decelerated motion. So altogether the accelerated motion, constant motion and decelerated motion, the car have travelled the distance that is 15 years. Okay, so we have to find the distance that is yes in terms of that is acceleration and time. Okay, acceleration and time. So what I am going to do for this question, that is I am going to draw the velocity time graph for this motion of the car. Okay, velocity time graph. Okay, this is a velocity time graph. Velocity time graph. So we know that the slope of the velocity time graph gives the acceleration, the area under the velocity time graph gives the displacement. Okay, displacement. So the car starts from rest and moves with moves with the constant acceleration f for a distance s. That is the slope of the curve, that is f. Okay, so the area under the velocity time graph, it is distance, the car have moved the distance. So after time t1, so it reaches a constant speed. Okay, it reaches a constant speed v. Okay, constant speed v. So after that the car continues at a constant speed. Okay, constant speed. Constant speed means acceleration 0, that is straight line. a straight line. That is for a time t. Okay. So after that the car starts to decelerate with a constant deceleration f2 and come to rest. So the constant deceleration, that is f by 2. So deceleration f by 2, that is the slope is double the slope of the first slope. Okay, f by 2. f by 2. So here the slope is double the slope. Okay. That is for the initial first part of the journey, the car has taken the time t1. So here it moves with the deceleration f by 2. So how much time the car has taken? That is the time 2 t1. Okay, 2 t1. So in time t1 it moved the distance s. In time t1, how much distance it will travel? That is 2s. Okay. So what is the distance traveled by the car with a constant speed? Because it is the question it is given, that is the total distance traveled is 15 s. So in accelerated motion and decelerated motion, the car has traveled the distance, that is 3s. So 12s, 15s minus 3s, that's equal to 12s. So the car has moved the distance, that is 12s, with the constant speed. Okay, constant speed. So clear? Then for the first part of the motion, that is accelerated motion, I am using the equation, that is v square minus u square is equal to 2as. Okay, so it reaches a constant speed, that is the final velocity. So the car starts from rest, that is initial velocity is 0. 2, what is the acceleration here? F. So yes. So v square is equal to 2fs. So v is equal to root of 2fs. V is equal to root of 2fs. Then next I am considering the second part of the journey, that is the car moves with a constant speed. Okay, moves with a constant speed. So velocity is equal to displacement by time. So displacement is equal to velocity into time. So what is the displacement mode that is the car moves? That is 12s. 12s equal to. So what is the velocity? The car moves with the constant velocity, that is v. So how much time? That is t. Okay. So that's equal to, instead of v is substitute, that is root of 2fs, that is into t. So 12s equal to root of 2fs into t. Squaring on both sides, that is 144 s square is equal to 2fs t square. Okay, t square. So s cancel, 144 cancel, that is 7, 2. Okay, so s is equal to 1 by 72 f t square. So that is the answer. S is equal to 1 by 72 f t square. So compare the options. So s is equal to f t, s is equal to 1 by 6 f t square, s is equal to 1 by 72 f t square. So that is the answer. So clear? So 12th question. So this is the velocity time graph given. Okay, velocity time graph of a motion of a body, linear motion of a body. Okay, so find the body find the displacement of the body displacement of the body. Find the displacement of the body in 5 seconds. Okay, 5 seconds. So we know that the area under the velocity time graph gives the displacement. Okay, displacement. So we have to find the displacement traveled by the body in 5 seconds. So 5 seconds means, so the area under this triangle, that is OAB, and the triangle, that is BCD, and the rectangle DEFG. Okay, DEFG. So the total area under this triangle and this rectangle will give the displacement traveled by the body. Okay, first consider that is triangle OAB. Okay, OAB. So what is the area? That is half into 1, 2, 3. Okay, base, that is 3 into what is the height? That is 2. Okay, so 2 cancel, that's equal to 3 meter. Then consider the triangle, that is BCD. Okay, BCD. So what is the area? That is half into base, that is 1 into height, that is -2. That is negative displacement. Okay, negative displacement. Negative velocity, that is negative displacement. That is the body comes back. Okay, comes back. So 2 cancel, that's equal to -1 meter. Then consider the rectangle, that is DEFG. DEFG. Okay, so what is the area? That is length into breadth, that is DG into DE. Okay, DE. DG, that is 4 into 5, that is 1 into DE, that is 1, that's equal to 1 meter. Okay, so the total displacement traveled by the body, that is 3 plus 3 minus 1. Okay, -1 plus 1. So -1 cancel, that's equal to 3 meters. So 3 meter is the displacement traveled by the body. Clear? So 13th problem. A body is at rest at x equal to 0 at a time t is equal to 0. It starts moving in the positive x direction with a constant acceleration. At the same instant, another body passes through x equal to 0, moving in the positive x direction with a constant speed. The position of the first body is given by x1 of t after time t, and that of second body x2 of t after the same interval. Which of the following graph correctly describes x1 minus x2 as a function of time? So in this question, the 4 options are given. So we have to clearly identify the x1 minus x2 versus time. So the motion of two bodies given. The first body starts from rest. Okay, starts from rest and moving with a constant acceleration. So the position of the first body, that is x1 of t after time t. So the position of the body is, first body is x1 of t and the second body is x2 of t. So first body, it starts from the origin and moving with a constant acceleration. So the position of the body, that is we can find with the equation s is equal to ut plus half at square. Okay, so the initial velocity is equal to 0. Origin starts from rest, so initial velocity is 0. So position of the first body s is equal to half at square. So x1 of t is equal to half at square. So at the same instant of time, another body moving through the origin, that is x equal to 0 with a constant velocity v. So the position of the body after time t, how we can find out? That is equal to vt. Okay, vt. So we have to find x1 minus x2. So x1 minus x2 is equal to half at square minus vt. Okay, so we have to plot if we plot the graph, that is x1 minus x2 and t, which one of the following graph, that is 4 graph, is the answer. Okay, so the position of the two bodies, that is x1 minus x2, is given by the equation that is x1 minus x2 is equal to half at square minus vt. Suppose time t is equal to 0, time t is equal to 0, that is x1 minus x2 is equal to 0, x2 is equal to 0. So the given graph, all the 4 graphs starts from the origin, that is x1 minus x2 is equal to 0. So from that we can't identify the answer. Okay, so all the for the given 4 graphs starts from the origin, that is so we can't identify the answer. Suppose x1 minus x2 half at square minus vt, so it is the function of time. Okay, function of time. So suppose I am finding the instantaneous slope, that is dx by dt. Okay, dx by dt is equal to half into 2 into at, okay, at minus v. Okay, minus v, dx by dt, that's equal to half into 2at minus v. So okay, 2 get cancelled, that's equal to at minus v. Okay, at minus v. So at a time t is equal to 0, time t is equal to 0, dx by dt is equal to minus v, that is slope is negative. At a time t is equal to 0, slope is negative. Okay, slope is negative from this graph. So draw the tangent at a time t is equal to 0. So this is 0, so draw the tangent here. Okay, draw the tangent here. So it gives the positive slope, a positive slope. At this draw the tangent. So here the slope is positive slope. At this position, draw the tangent. Here also the slope is positive. So at the time t is equal to 0, that is like this. So here the slope is greater than 90 degree. So greater than 90 degree. So here the slope is negative. Slope is negative. Okay, negative. So here this graph, that is at a time t is equal to 0, slope is positive. Here also slope is positive. Here also slope is positive. For this curve, that is slope is negative. Okay, slope is negative. Negative. Okay, so this graph should be the answer, that is x1 minus x2 is equal to, so option C is the answer. Okay, C is equal to answer. So 14th question. Okay, so consider an acceleration time graph. So consider the acceleration time graph. Acceleration time graph. Okay. Suppose the body, if the body starts from rest, how much distance it will travel? How much distance it will travel? It will travel before it comes to rest. It comes to rest. So suppose the body starts from rest, how much distance it will travel before it come to rest? So this is the acceleration time graph. So from the acceleration time graph we can't find the distance traveled by the body. So we can find the distance traveled by the body from the velocity time graph. So what we are going to do is we are going to draw a velocity time graph for this acceleration time graph. Okay, acceleration time graph. To velocity time graph. So from the acceleration time graph, so the body starts from rest. Okay, starts from rest. It moves with a constant acceleration too. Okay, constant acceleration for the time first 2 seconds. For the time 2 seconds, it moves with a constant acceleration. Okay, constant acceleration. So the body starts from rest means it from the origin we can start the velocity time graph. Okay, for the time 2 seconds, how much velocity it travel? That is, we can use the equation, that is v is equal to u plus at, because the body moves with the constant acceleration. Okay, constant acceleration. So v is equal to, if the body starts from rest, that is u0, that is 2 into, for the time 2 seconds, 2. So that is equal to 4 meter. Okay, 4 meter. So the body starts from rest. So for the time 2 seconds, the body traveled 4 meter. 4 meter. ठीक है? Next, from 4, next 2 seconds, from time 2 to 4 seconds, the body moved with the acceleration 1. So that is 1 meter per second square. So 2 to 4 seconds the body moved the acceleration, that is 1 meter per second square. So velocity, so v is equal to u plus at. So v is equal to initial velocity, that is from this point the velocity is 4. Okay, 4 plus acceleration, that is 1 into time 2. So that's equal to 6 meter. Okay, 6 meter. So for the time 4 seconds it moved with the velocity, that is 6 6 meter, right? 6 meter. So after that, the body moves with the deceleration, that is minus 1.5. That is, the body moves with the deceleration. So in the question it is given, if the body starts from rest, how much distance it will travel before it comes to rest. Finally, the body comes to rest. Okay, it is given in the question. So in what time? So we have to find at what time the body comes to rest. Okay, comes to rest. So again we are using the equation V is equal to U plus AT. So finally the body comes to rest. So therefore the final velocity is 0. Initial velocity from 6 onwards the body starts to decelerate. So initial velocity is 6 plus the body moves with the deceleration, that is minus 1.5 at a time. So time we have to find out. Okay. So minus 1.5 into minus 6. So minus 1.5 t. So minus minus cancel. T is equal to 6 divided by 1.5. That's equal to 4. So the body at the time, that is 4 seconds, starts to decelerate, and finally it comes to the rest at 4 seconds. That means 4 to 4. Therefore at 8 seconds the body comes to rest. So that is the velocity time graph. So this velocity time graph gives the displacement traveled by the body. So the area under the velocity time graph, gives the displacement traveled by the body. So the entire area. So this triangle. So first, second triangle, this rectangle 3, again this triangle. So this much area gives the distance traveled by the body. So first triangle. So first. Okay. So what is the area? Half into 2 into 4. 2 get cancelled. So that's equal to 4 meter. Then second triangle. Okay. Second triangle. So half into 2 into 2. So 2 get cancelled. That's equal to 2 meter. Okay. So third rectangle. Okay. Third rectangle. So 2 into area. 2 into 4. So that's equal to 8 meter. Then again fourth triangle. Okay. 4 to 8. That's half into 4 into 6. So 2 get cancelled. That's equal to 12 meters. So the total distance traveled by the body. So distance equal to 4 plus 2 plus 8 plus 12. So 12 plus 8, 20, 24, 2. That is 26 meter. 26 meter. So 15th question. A train starts from a station. Okay. A train starts from a station A and moves with a constant acceleration A1. Okay. So for it moves with a constant acceleration for some distance, and it starts to decelerate. So here it reaches a constant velocity, that is Vm, and from this point onwards it starts to decelerate with a constant deceleration A2, and it comes to rest on the station B. Okay, B. The total time taken by the train from the station A to B is, that is 4 minutes. Okay, 4 minutes. And the distance between the two stations is, that is 4 kilometer. 4 kilometer. So the distance between the two stations is 4 kilometer. Then show that show that 1 by a1 plus 1 by a2 is equal to 2. So we have to show that 1 by a1, that is the first acceleration, then plus 1 by a2, that is the deceleration, is equal to 2. Okay, so understand the question. A train starts from the station A, and it moves with a constant acceleration a1, and at a particular point it reaches a constant velocity, that is Vm. So from that maximum velocity Vm. So from that point onwards the train starts to decelerate, okay, with a constant deceleration a2, and it comes to rest on the station B. So the time taken by the train to travel from the station A to B is, that is 4 minutes, and the distance between the two stations is 4 km. Show that 1 by a1 plus 1 by a2 is equal to 2. So what I am going to that is solution, that is draw the velocity time graph. Okay, velocity time graph. So the train starts from rest and moves with a constant acceleration, that is velocity time graph. Okay, velocity time graph. So it moves with the acceleration, that is a1, and at this point it reaches a maximum velocity, that is Vm. Okay, Vm. So from that point onwards it starts to decelerate with a constant deceleration, that is a2, and finally it comes to rest. Okay, so the time, the first portion of the journey, that is for T1 is the time taken by the train to reach the maximum velocity Vm, and T2 is the time taken by the train to from the maximum velocity to come to rest. Okay, so T2 is the time. So we have given, that is suppose S1 is the distance traveled by the train. Okay, so S1 is the distance and S2 is the distance traveled by the train. Okay, so we have given, that is T1 plus, the question is given, T1 plus T2 is equal to 4, S1 plus S2 is equal to, that is 4 minutes, that is 4 kilometer. Okay, 4 kilometer. Okay, so S1 plus S2 is equal to, from this S1 plus F2 is equal to, so the total displacement or total distance traveled by the train, that is equal to half into T1 plus T2. Okay, T1 plus T2 into, that is height Vm. Okay, so S1 plus S2 given, that is 4, is equal to 1 by 2 into T1 plus T2, that is also 4 into Vm. So 2 get cancelled. Okay, so therefore Vm is equal to 2 kilometer per minute. Okay, 2 kilometer per minute. So that is the maximum velocity. Okay, so from the graph, suppose theta is the angle here. Okay, theta is the angle here. So tan theta is equal to perpendicular by base, that is Vm by T1. Okay, so tan theta is nothing but, that is acceleration, that is slope of the curve, that is nothing but acceleration. Okay, velocity time graph. So slope of the velocity time graph gives the acceleration. So a1 is equal to Vm. So we have find, that is 2 by T1. So from this T1 is equal to 2 by a1. Okay. So similarly we can write, that is a2 is equal to 2 by T2. Okay, T by T2. So T2 is equal to 2 by a2. Okay, so substitute the base values on this equation. So T1 plus T2. So T1 plus T2 is equal to 4. So what is T1? That is 2 by a1 plus what is T2? That is 2 by a2, that's equal to 4. Take 2 commonly outside. So 2 into 1 by a1 plus 1 by a2 is equal to 4. Therefore, 1 by a1 plus 1 by a2 is equal to 2. Okay, 2. So that we have to prove. That is 1 by a1 plus 1 by a2 is equal to 2. Clear? So the next problem, that is 16th question. So consider a velocity displacement graph. Velocity displacement graph. Velocity displacement graph. Velocity meter per second, displacement meter. Okay. So this correspond to 6. 2. So 18. 10. Okay, 10. So find acceleration. Find acceleration when displacement x equal to 3 meter. X equal to 3. So the given graph is velocity, not velocity time graph, velocity displacement graph. Okay, velocity displacement graph. So we have to find the acceleration when displacement is equal to 3 meter. So when velocity in terms of, that is velocity is a function in terms of that is displacement. So we have studied on formula to find the acceleration. So acceleration is equal to v into dv by dx. Okay, acceleration is equal to v into dv by dx. So where dv by dx, that is slope of the curve. Okay, slope of the curve. Okay, here, so slope of the curve means that is dv by dx equal to, that is y2 minus y1 divided by x2 minus x1. Okay, so x1 y1, x2 y2. So here so this point I am taking, that is A and this is B. Okay, B. So x1 y1, so here that is x, that is 2, y1 that is 18. So this point x1 that is 6, y1 that is 10. Okay, so substitute the values. So y2 minus, that is 6 minus y1 that is 18 divided by x2, x2 that is 6 minus x1 that is 2. So that's equal to that is y2 that is 10. Okay, y2 10. So 10 minus 18. So that's equal to minus 8 divided by 4. So that's equal to minus 2. dv by dx equal to minus 2. Okay, minus 2. So what is v? That is v is the velocity corresponding to the displacement at that is 3 meter. Okay, 3 meter. So 3. Okay, 3. So that is V. Okay. So from this these two triangles, that is AB ABC and this triangle DE, okay. So this triangle ABC and ADs are similar triangles, okay, similar triangles. So from this we can write that is similar triangle means we can write that is AC by CB is equal to AD by D. Okay. So what is AC? AC means 10 to 18 minus 10, that is 8. Okay, 8 by CB. So that is 2 to 6, that is 4 is equal to what is AD? AD means that is 18 minus V divided by DE, that is 2 to 3, that is 1. Okay, so 2. So 18 minus V is equal to 2. Okay, 2. So V is equal to, that is 16. V is equal to 16. Okay. So what is acceleration? Acceleration is equal to V into dV by dx. So what is V? That is 16. 16 into what is dV by dx? That is minus 2. So that's equal to minus 32 meter per second square. So that is the answer. Okay. So here, so the velocity displacement graph. So we are using the formula A is equal to V into dV by dx. dV by dx is nothing but the slope of the curve. So we find the slope of the curve using dV by dx equal to y2 minus y1 by x2 minus x1. So the line is like that. So the slope is greater than 90 degrees. So that is negative slope. So dV by dx equal to minus 2. So V is nothing but the velocity corresponding to the displacement, that is 3 meters. So from this graph we are finding that if 3 is equal to corresponding the velocity at the displacement 3 is displacement x equal to 3 meter. Okay, so if we find that is V is equal to 6 meter by using the properties of similar triangles, we find the velocity, that is V is equal to 16 meter. So substitute the values, we get the answer, that is acceleration is equal to minus 32 meter per second square. Clear? 17th problem. Consider an acceleration time graph. Acceleration time graph. Consider the acceleration time graph. Find the equivalent velocity time graph. Find the velocity time graph. Option A, option B, option C, option D. So this is the acceleration time graph. So we have to find the equivalent velocity time graph. So here the acceleration is constant. Okay, acceleration is constant. So we know that the slope of the velocity time graph is acceleration. So if you want to get the constant, that is constant acceleration, means the slope must be constant. So here slope is constant. Okay, slope is constant. So for each and every point, if you find the slope, that is slope is constant. So here the first thing is, that is acceleration positive, acceleration constant. Okay, constant. So here, that is the angle, the slope of the angle is less than 90 degree. So that is acceleration is positive. Tan theta positive. Tan theta positive means slope positive. Slope positive means acceleration positive. Okay, acceleration positive. And also, if you find the angle at any points, each and every points, if you find the angle is constant. Okay, angle is constant. So acceleration, therefore acceleration is constant. So after that, acceleration becomes 0. So here, so from this point, that is acceleration, that is horizontal straight line, that is slope is equal to 0. Slope is equal to 0 means, that is acceleration is equal to 0. Here slope is equal to 0. So after that, again, that is positive acceleration. Okay, positive acceleration, acceleration increases, that is from 0 acceleration increases, that is also acceleration is positive. Okay, positive. So here the line is like this. Okay, so acceleration increases, acceleration positive. Okay, acceleration positive, like this. Okay, so this is the equivalent velocity time graph for this acceleration time graph. So option B is the answer. So no other graph matches with this acceleration time graph. Okay, time graph. So here acceleration positive, acceleration 0, then acceleration becomes negative here. Okay, negative here. Here acceleration from the starting itself, acceleration is negative. Here also from the starting itself, acceleration is negative. So in our case, that is the acceleration is always positive. Always positive. So this graph don't match with this graph. So first acceleration positive, acceleration constant, then acceleration becomes 0, then acceleration again, that is constant, acceleration positive. So this graph only matches with this acceleration time graph. Okay. So 18th question. A body starts from rest and moving with the constant acceleration. Okay, moving with constant acceleration. So the variation of speed with the displacement x is. So find the curve. Find the graph. Find the graph of speed versus distance. So a body starts from rest and moving with a constant acceleration. So find the graph of speed versus distance. Okay, speed versus distance. Option A, is velocity, displacement. Option B, option C, A body starts from rest and moving with constant acceleration. So the variation of speed with the displacement x is. So we have to find the current curve. So v square, I am using the equation v square minus u square is equal to 2as. Okay. So the body starts from rest. So v square minus initial velocity 0 is equal to 2as. So v square is equal to 2as. Okay, 2as. So the final velocity and displacement relation is like this: v square is equal to 2as. So it is just like the equation, that is y square is equal to, that is 4ax. That is the standard equation of a parabola. Okay, standard equation of a parabola. So we have, that is 4 types of parabola. Okay, that is y square is equal to 4ax. Okay, 4ax. It is y square is equal to 4ax. Okay, so this is the parabola. Y square is equal to 4ax. So this is y axis and this is x axis. Then y square is equal to minus 4ax. Minus 4ax. So parabola. Y square is equal to minus 4ax. Then x square is equal to 4ay. X square is equal to 4ay. And x square is equal to minus 4ay. These are the 4 types of parabola. Okay, y square is equal to 4ax. So x means y is equal to 4ax means it is x axis. Okay, x axis. Y square is equal to minus 4ax means it is in the opposite direction. The parabola is in the opposite direction. Okay. So x square is equal to 4ay. Okay, that is x square. Square term in x, that is 4a, means the parabola in y axis. Okay, y axis. X square is equal to minus 4ay means opposite parabola. So you have to remember these 4 standard 4 parabolas and the equations, the corresponding equations. Okay, then you have to know about the symmetry of parabola also. Symmetry of parabola. Symmetry of parabola. Symmetry of parabola. So y square is equal to 4ax. Y square is equal to 4ax. Okay. So x equal to y square by 4a. Replace minus y with y. Okay, minus y with y. So x equal to minus y square divided by 4a. That's equal to y square by 4. So again we are getting the same value. So x equal to y square is equal to 4ax. So x equal to y square by 4a. So replace minus y with y. Replace minus y. Sorry, replace y with minus y. Okay, replace y with minus y. So x equal to minus y the whole square divided by 4a. That's equal to y square by 4a. So we are, even though we are replacing y with minus y, we are getting the same value. So x equal to y square by 4a. So this parabola, that is y square is equal to 4ax. This parabola is called, this parabola is symmetric about x-axis. Symmetric about x-axis. Symmetric about x-axis. This parabola is called symmetric about x-axis. Okay. Similarly, x square is equal to 4ay. Okay, x square is equal to 4ay. So from this, y is equal to x square by 4a. So replace x with minus x. So y is equal to minus x square divided by 4a. So y is equal to x square by 4a. So this parabola x square is equal to 4ay is called. Even though we are replacing x with minus x, we are getting the same equation, y is equal to x square by 4a. So this parabola x square is equal to 4ay is called symmetric about y-axis. Symmetric about y-axis. So these are the things you have to remember always. Okay, keep in mind. So the four types of parabola, and symmetric about x-axis and symmetric about y-axis. Okay. So come to our problem, that is the fourth graph is like this. So velocity time graph. Okay, velocity time graph like this. So an object, we are using the constant, the body is moving, the body starts from rest and moving with a constant acceleration. So we are using the kinematic equation v square minus u square is equal to 2as. So v square minus 0 is equal to 2as. So v square is equal to 2as. So it corresponds to the equation, that is y square is equal to 4ax. So definitely this equation resembles the equation of a parabola. Okay, parabola. Then so v square is equal to 2as. So replace v with minus v. So minus v square is equal to 2as. So again we are getting, that is v square is equal to 2as. So from this what we can conclude? So the equation, that is the graph, is symmetric about the displacement axis. So from this graph, which that is this is not, okay, this is not a parabola. So this is not a parabola. This is a parabola, and this is a parabola, and this is also a parabola. Okay, parabola. So which equation? That is v square is equal to 2as. That is, that equation resembles the equation of a parabola. That is, the shape of the curve must be a parabola. So parabola. So here in our answer, two parabolas are there. So to confirm that which parabola, so we are using, that is, to find the symmetry of the parabola. So for that I am putting, that is replace v with minus v. So minus v square is equal to 2as. So v square is equal to 2as. So from this what we can conclude, that if the parabola is symmetric about the displacement axis. Symmetric about displacement axis is, this is the answer. Okay, this is the answer. Clear? So problem number 19. Okay, so consider a tower of height 900 meter. Okay, a boy is of height 900 meter. Meter. A boy is standing on the top of the tower. A boy is standing he is projected vertically upwards. He projected a ball vertically upwards with a velocity u is equal to, that is 20 meter per second. Meter per second. So, what is the trajectory of the ball? So, the ball goes upwards, that is, it reaches a maximum height. At that point, the velocity of the ball becomes 0. It comes to the original position and it reaches the ground. Okay, reaches the ground. So, this is the trajectory of the ball. Okay, trajectory of the ball. So, at that point, the velocity at the top, that is velocity is equal to 0. So, our question is draw the displacement time graph for the motion of the ball. Motion of the ball. Take the point of projection as the origin. Okay. So this is a tower of height 100 meter. A boy is standing on the top of the tower. He projected a ball vertically upwards starting with an initial velocity of 20 meter per second. So this is the trajectory of the ball. That is, the ball, as the ball goes upwards, the velocity velocity decreases and it reaches a maximum point where the velocity becomes 0, and after that the ball comes down to the original position and finally to the ground. So we have to find the draw the displacement time graph for the motion of the ball. Okay. When the ball is projected, that is time t is equal to 0. Okay, t is equal to 0. When the ball reaches the maximum height, so maximum height, what is the time? So I am using the equation v is equal to u plus at. So at that point the velocity becomes 0, is equal to initial velocity, that is 20, plus acceleration always minus, that is minus 10t. Okay, so minus 10t is equal to minus 20. So t is equal to 2 seconds. Okay, so when the time t is equal to 2 seconds, the ball reaches the maximum height. Okay, so we know that when the ball returns to the original position, mean position, what is the time? That is, time is equal to 4 seconds. Okay, that is, the time for the upward motion and the downward motion is the same. So the time for the reaches that t is equal to 2 seconds, t is equal to 4 seconds, reaches the height. So what is the time taken by the ball to reach the ground? So From this I am considering the motion, the ball reaches the maximum height okay, maximum height and comes down to the ground. So we can find the time, that is t is equal to root of from this equation, that is from this point onwards I am considering the motion. The ball it's just like the free fall, okay, free fall. So 100 plus okay, so what is the maximum height reached by the ball? That is the distance maximum height reached by the ball, that is v square minus u square is equal to 2as. Okay, v square minus u square is equal to 2as. So at the topmost position the ball's velocity is 0 minus initial velocity, that is 20 square is equal to 2 into minus 10 into s, we have to find out. This minus cancel. So s is equal to 20 into 20 divided by 2 into 10. So cancel, 2 to cancel. So s is equal to 20 meter. S is equal to 20 meters. So from the mean position the ball reached the height, that is 20 meter. Okay, 20 meter. So how much time it will take from this point to this point? How much time the ball will take to reach the ground? So we can use the equation, that is this equation only, s is equal to ut plus half at square. Okay, half at square. So from this equation we can find, that is t is equal to root of 2h by a. Okay, that's equal to root of 2 into, that is 100 plus 20, that is 120 divided by a, that is 10. Okay, cancel 12 into 2, that is 24. That's equal to root of 6 into 4, that is 2 root 6 second. 2 root 6 second. So the time taken by the ball to reach the ground is t is equal to 2 root 6 second. Okay, second. So now we can draw the displacement time graph. Okay, displacement time graph. Displacement time graph. So time t is equal to 0. T is equal to 0. When the ball reaches the height, this height, time t is equal to that is 2 seconds. When the ball returns to the mean position, time is equal to, that is 4 seconds. When the ball reaches the ground, the time taken is 2 root 6 seconds. Okay, 2 root 6 seconds. Okay, 2 root 6 seconds. Then the displacement traveled by the body when time t is equal to 0, distance 0. When time t is equal to 2 seconds, that is 20 meter. Am I right? That is 20 meter. Okay, 20 meters. So this is displacement time graph. Okay, displacement time graph. 20 meter. So when the time the ball reaches to the mean position, that is 4 seconds, that is the ball comes to the original position, that is displacement is 0. Okay, displacement is 0. When the ball, that is at the time 2 root 6 seconds, it reaches the height, that is minus 100 meter. Am I right? Minus 100 meter. That is minus 100 meter. Minus 100. Okay, so now this time, that is 4 seconds, it becomes 0. 2 root 6 that is it becomes okay. So we have to draw the graph, okay, connecting these points. So according to that is in such a way that we have to draw the graph in such a way that the graph gives the velocity, because from the distance displacement velocity graph we have to find the velocity, okay, velocity. So according to that only we have to draw the graph. So when the ball is projected, when the ball goes upwards, it is up to 2 seconds, that is the velocity decreases, okay, velocity decreases. So the curve is like this. Okay, it's like this. Then from this on that is the velocity increases, okay, velocity at this point the velocity becomes 0, and after that the velocity increases, okay, that is from this point to this point up to this point, that is the velocity increases. Also the velocity is negative. Here the velocity is positive, okay, velocity is positive, that is if you draw the tangent, that is it is less than 90 degree, so we will get that is velocity positive. So here if you draw the tangent, that is velocity it is velocity negative increasing, velocity negative increasing, okay. So up to from this point to up to this point, that is the single journey, that is velocity negative increasing, okay, velocity negative increasing, right, okay. So this is the displacement time graph of the motion of the ball. Clear? Next is for the same case draw the distance time graph. Distance time graph, okay. So when we draw the displacement distance time graph means the distance is always positive. So in the previous case we have drawn the displacement time graph. So displacement time graph, so the motion of the ball from this point to this point only, that is displacement is positive, okay. When the ball comes down, the displacement is negative, okay, displacement is negative. So here when you draw the distance time graph, distance is always positively, okay, positively. So according to that we have to draw the graph. So how to draw the distance time graph? Distance time graph, when time t is equal to 0, distance equal to 0. When time t is equal to 2 seconds, the distance traveled by the ball is 20 meter, okay. The distance traveled by the meter, that is s is equal to 20 meter. When time t is equal to 4 seconds, the distance traveled by the body, that is 20 plus 20, that is 40 meter, okay. When time t is equal to 2 root 6 seconds, that is the distance traveled by the body is 40 plus 100, that is 140 meter, okay. So according to that we have to draw the graph, okay. So this is a distance time graph. When time t is equal to 0, the distance equal to 0. When time t is equal to 2 seconds, the distance traveled by the ball is, that is 20 meter, okay, 20 meter. When time t is equal to 4 seconds, okay, 4 seconds, The distance traveled by the ball is 40 meter. This is 20. This is 40. Meter. When time t is equal to 2 root 6, okay, 2 root 6 seconds. Seconds. 4 seconds, 2 root 6 seconds. The distance traveled by the ball, that is 140 meter. Is 140 meter. Okay, so from up to time 2 seconds, that is the speed decreases. Okay, so when you consider the motion of the ball from this point to this point, that is the time 2 seconds, the speed decreases. So from this point to this point, the speed increases. Okay, speed increases. So the slope of the distance time graph gives the speed. So according to that, we have to draw the graph. So speed decreases, though the curve is like this. Okay, curve is like this. So from this point to this point, the speed increases. So how will be the curve? It will be the curve. So again speed increases. So the curve is like this. Like this. So this point to time 2 seconds, the speed decreases. Speed is always positive. Okay, speed is always positive. So the curve, that is, if you draw the tangent, that is speed decreases. Okay, speed decreases. So from this point to, that is 4 seconds to 2 root 6 seconds. From time 2 seconds to 4 seconds, then 4 seconds to 2 root 6 seconds, the speed increases. So the curve will go like this. Okay. So this is the distance time graph for the same case. Okay. So draw the velocity time graph for the motion of the ball. Motion of the ball. So at a time t is equal to 0, what is the velocity? Velocity is equal to 20 meter per second. T is equal to 2 seconds, velocity is equal to 0. T is equal to 4 seconds, velocity is equal to minus 20 meter per second. Okay. When the ball returns to the mean position, it comes with the velocity as that of the ball is projected. Okay. So here in the downward direction, so velocity is negative. So t is equal to 2 root 6 seconds. So 2 root 6 seconds. What is the velocity? V is equal to root of 2gh. So that's equal to root of 2 into 10 into what is h? That is 120. So that's equal to 20 root 6. Okay, 20 root 6. Okay, so connecting all these points, we can draw the graph, velocity time graph. Okay, velocity time graph. So time t is equal to 2 seconds, 4 seconds. Okay, t is equal to 4 seconds, and t is equal to 2 root 6. T is equal to 2 root 6. So t is equal to 20. At the time t is equal to, that is 20 meter per second. That is velocity time graph. Okay, velocity time graph, that is 20 meter per second. T is equal to 2 seconds. That is 2 seconds. That is velocity is equal to 0. Velocity is equal to 0. Okay, t is equal to 4 seconds. That is minus 20. Minus 20. So t is equal to, that is 20 root 6. 2 root 6, 6 means it is 20 root 6. Root 6. So connecting all these points, you have to draw the graph. Okay. So when time t is equal to 0, it is velocity 0. Okay, velocity 0. Slight bend is there in the graph. Okay. So this is the velocity time graph. Okay, velocity time graph. Velocity time graph. Velocity time graph. At a time t is equal to 0, the velocity 20. At a time t is equal to 2 seconds, the ball t is equal to 0 seconds means ball is projected. At a time t is equal to 2 seconds means the ball reaches the maximum height, the velocity becomes 0. Then t is equal to 4 seconds means the ball returns to the mean position, that is 20, minus 20. Okay, minus 20 root 6. Okay, then t is equal to 20, that is the time t is equal to 2 root 6 means the velocity is minus 20 root 6. So this is the graph of this. So throughout it is a straight line graph, because throughout the concept velocity, that is acceleration, is constant. Acceleration is constant. Okay, acceleration is constant. So we will get the straight line graph. So when we draw the velocity time graph, we have to consider about acceleration, because the slope of the velocity time graph gives the acceleration. So throughout the motion, acceleration is constant. Always that is minus, so always 9.8. So acceleration is constant. So the velocity time graph is always straight line. Okay, straight line. Clear? A rocket is projected vertically upwards. That is 20th problem. A rocket is projected vertically upwards. Okay, upwards. So the velocity time graph of the rocket is given. It is 20, 40, 60, 80, 120. Okay. Velocity time graph. Velocity time graph. So that is 1000 meter per second. Okay, so what is the maximum height attained by the rocket? What is the maximum height attained by the rocket? So the the area under the velocity time graph gives the distance traveled by the object. Distance traveled by the object. So from 120 onwards, that is the velocity goes in the negative direction. Okay, velocity goes in the negative direction. That is the time t is equal to 120 seconds only the rocket comes down. Okay, so at that up to 120 seconds the rocket goes in the upward direction. So the area under this velocity time curve gives the maximum height attained by the rocket. Clear? So maximum height is equal to half into base, that is 120 into, that is maximum, that is 1000. Okay, 1000. So 60. So 60 it is 60 into 1000. 16,000. That is 60 kilometer. 60 kilometer is the answer. Okay, 60 kilometer is the answer. So with this I conclude this session. That is the problem section of graphical analysis of motion. So totally 20 problems I have solved in this session, that is for graphical analysis of motion. Because graphical analysis of motion, it is a little bit confusing session. So velocity time graph, displacement time graph, acceleration time graph, how the acceleration time graph is converted to velocity time graph. So a little bit confusing. That's why I solved 20 problems of different types. Okay, different types in this section. So do the problems and practice much problems as much as possible. Then only the concept will be very thorough for you. Okay, so in the next topic we will meet with, that is relative velocity, the last topic in the that is motion in a straight line. Stay tuned. Bye.